All right, guys. Hello. Welcome back. Today I am going to be working on a first order differential equation. With an initial condition, y equals 0 equals 4. I've decided to work on this video just because I know last time I uploaded the Laplace transform video, which is way ahead, right? But I am going to be starting this differential equations course, so I'm going to be releasing videos working on different problems. In differential equations, right? And I'm going to start all the way from the beginning and just work my way down. So today we have this differential equation right here that can be solved using separation of variables, right? So let's go ahead and get started. Okay, so I'm going to go ahead and rewrite this. Let me see. Okay, we go ahead and change colors. Okay, there we go. So let's go ahead and rewrite this as dy over dx plus y cosine of x equals 2 cosine x. I always like to rewrite my question, right? Okay, so what I'm gonna go ahead and start by doing is isolating my dy over dx. So I'm going to do minus y cosine x minus y cosine of x. This is gonna go away, right? So now we are going to have dy over dx, which is then equal to 2 cosine of x minus y cosine of x. Okay, nice. So right here we can actually go ahead and factor this equation right here, right? So what we can do is that we can do 2 minus y, and we'll have cosine of x on the outside, and we have over dy dx. Okay, sweet. So what I like to do is that I like to multiply both sides by dx, right? So this is just gonna go ahead and go away right there. And so now we are going to have dy, which is equal to 2 minus y cosine of x dx. In which now I can go ahead and divide, right? Because we're doing separation of variables. And I'll go ahead and explain this at the end, right? So now we have this, right? So I'm going to rewrite this. So we have dy over 2 minus y, which is then equal to cosine of x dx. And so now, right, we can go ahead and integrate both sides. But before I do that, I'm going to go ahead and rewrite this as 1 over 2 minus y dy equals to cosine of x. All right, so this is why we needed to separate this, right, this differential equation, because we can get it into this form in which we can now integrate, and that's basically what separation of variables does, right? We just want to separate this equation into its variable form in a way, and that way we can go ahead and integrate, right? So let me go ahead and integrate. Okay, so this right here, the left side is going to be equal to negative ln of 2 minus y. So basically, you know, you go through the integral of this, you end up with negative ln of 2 minus y. So yeah, and now for the right side, we'll have sine of x plus c. It's just a very elementary integral. We went over, I have a video on this. So it's just the integral of cosine, which is sine. And because of the loss of logarithms, right, rules of logarithms, we can go ahead and write this left side as ln of 1 over 2 minus y. I'm not going to get too much into depth with this because this is just algebra at this point, guys. So, I mean, if you want me to go over this, just go ahead and drop a comment, or if you want me to go through those algebraic steps. But by now, I think we should all be comfortable working with the algebra. So now we have sine of x plus c. And so now we want to go ahead and isolate, right? So the left side, as a matter of fact. So we're going to go ahead and take exponential of both sides. So now the left side is going to drop the ln. So now let me go ahead and change colors, where we are going to have 1 over 2 minus y, which is then equal to e to the sine of x plus c. And basically, with this, I can go ahead and rewrite the right side, just because this, again, this is just algebra, right? But based on what we have up here, there's a rule, right, that says that I could go ahead and write this as, this is just a constant, so I'm going to go ahead and write this as k e to the sine of x. Okay, so now I am going to have 1 over 2 minus y, which is going to equal k e to the sine of x. Okay, but remember, now we have an initial, so this right here would be our general solution for this differential equation, right? However, we have a initial condition, which is y equals 0 equals 4, right? So now we have to work that we could find that particular solution. So basically, with this, we're just gonna have to play around with it and you know, work on our solution. All right, guys. So yeah, we have that initial condition. So let me go ahead and write this. So 2 minus y equals k e to the sine of x. Right, so we have y sub 0 equals 4. So now with this, what we can go ahead and do is that we'll go ahead and write this as 1 over 2 minus 4. So the initial condition, k, which is equal to k e to the sine of 0. And if we look at this, right, the sine of 0 is just 0, and e to the 0 is just 1, right? So now we're going to have k by itself. So over here, we're going to evaluate the left side, which is just going to be 1 over 2 minus 4, which is just going to be negative 1/2, right? So that's what we have. So we have negative 1/2, which is equal to k. So we have found k. Now let's go back to our general solution. And now we can go ahead and evaluate this in there, right? So we'll have 1 over 2 minus y. 1 over 2 minus y, which is equal, which is equal to negative 1/2 e to the sine of x, right? Because we already found out our k. Now what we can go ahead and do is just do some algebra here. So we're gonna just multiply both sides by 2. So now we will have 2 over 2 minus y, which is then equal to negative e to the sine of x. And then by some algebraic manipulation, right, we're gonna go and have 2 over e sine to the x, which is then equal to y minus 2. Now we can go ahead and move the denominator up to the numerator. So once this happens, so we'll have 2e to the negative sine of x, which is then equal to y minus 2, which can do a plus 2, and our solution to this differential equation, or this particular, or the particular solution to this, will be 2e to the negative sine of x plus 2. So this is what y is equal to at the end of the day, right? So this is how you solve a first order differential equation using separation of variables. If you have any questions, please feel free to leave them down below. I hope this helps, and I'll see you all on the next video. Thank you.